Hello everyone. Today we'll be solving Cambridge iGCSE Chemistry Paper 4 Theory Extended February-March 2021 0620 Paper 42. Question number 1. The table shows the number of protons, neutrons, and electrons in particles A to I. We can see from particles A to I. Answer the following questions about the particles A to I. Each letter may be used once, more than once, or not at all. State which of the particles in A to I is an anion. So we know an anion will have more number of electrons than the number of protons. We can see E has more number of electrons than the number of protons. The number of protons is 16 and the number of electrons is 18. So E is the correct answer. The next question says, are cations? So to be a cation, the number of electrons must be less than number of protons. We can see there is a total of 20 protons here. However, there is only 20 electrons. So it's going to be a cation. So I is a cation. Other than that, we can see the number of protons here is 1. However, the number of electrons is 0. So A is also a cation. Are noble gas atoms. In order to be a noble gas atom, it must have a noble gas, noble gas electronic configuration. So we know 18 stands for, proton number 18 stands for argon. And proton number 10 stands for neon. Neon has an electronic configuration of 2,8. Argon has an electronic configuration of 2,8,8. So it will be D and G. Is a halogen atom. In order to be a halogen atom, it must belong to group 7. We can see element here, this one, the 17, it belongs to group 7. So this is chlorine, electronic configuration 287. So that is the only one. So chlorine. So it will be F. F is chlorine, which is a halogen. Okay. 5 is a group 1 atom. Group 1 atom must have 1 electron in their outer shell. So H has 1 electron in its outer shell. You can see H has 1 electron in its outer shell. So 19 stands for potassium. Electronic configuration 2881. So H have the same nucleon number. Having the same nucleon number means having the same mass number. The number of protons and neutrons must add up to the same numbers. 20 plus 20 is 40. 19 plus 20 is 39. So it doesn't match. 18 plus 22, however, is 40. So G and I will be the correct answer. So proton number, both of these adds up. This adds up to give 40. This one also adds up to give 40. So that's how we know that they have the same nucleon number. Causes acidity in aqueous solution. So basically, aqueous solution, acidity is caused by H plus ions. And having proton number 1 means hydrogen. So this is H plus ion. So A will be the answer. Is used to determine the relative atomic mass of elements. All right. Relative atomic mass of elements is determined by carbon 12. So anything that represents carbon 12 over here, 6 and 6. All right, proton number 6 is carbon. So this is C12. And so the answer is B for this one. Explain why B and C are isotopes of the same element. All right. So B and C are isotopes of the same element. B and C have same proton number, but different neutron number or mass number. Question number 2. The elements shown are gases at room temperature and pressure: hydrogen, nitrogen, oxygen, chlorine. State which one of these gases is green. We know that chlorine is a green gas. So chlorine. The gases shown exist as a diatomic molecule. State the name of another element that has diatomic molecule and is a gas at room temperature and pressure. So we know fluorine is also a gas and it is a diatomic molecule at room temperature and pressure. When separate samples of each of these gases are placed in a container, they will diffuse. Describe why gases diffuse. So basically, gases will diffuse because of the random motion of particles. Gases diffuse due to the random motion of particles. Question number 2C2. State which of these four gases has the highest rate of diffusion. Explain your answer. So basically, out of all of these gas, the one that is going to have the lowest molecular mass is going to have the highest rate of diffusion. So hydrogen is H2, has a molecular mass of 2. Nitrogen is N2, has a molecular mass of 28. Oxygen is O2, has a molecular mass of 32. Chlorine is Cl2, has a molecular mass of 71. So the gas that will have the highest rate of diffusion will be hydrogen. Explanation: because it has the lowest molecular mass. Part D. Nitrogen, oxygen, and other substances are found in clean, dry air. State the percentage of nitrogen in clean, dry air. So in clean, dry air, percentage of nitrogen is 78. Other than nitrogen and oxygen, identify another element found in clean, dry air. In clean, dry air, we can find argon. Identify a compound found in clean, dry air. A compound found in clean, dry air is carbon dioxide. Nitrogen and oxygen can be separated from liquid air. State the name of this process. This process is called fractional distillation because they have difference in boiling point. So it's going to be fractional, which is 1 mark, and the word distillation is going to have the other mark. This question is about ammonia. Nitrogen reacts with hydrogen to form ammonia in an industrial process. Nitrogen plus hydrogen produces 2 ammonia. Name this industrial process. The production of nitrogen and hydrogen, the production of ammonia by reacting nitrogen and hydrogen is called Haber process. So industrial process will be Haber, named after the scientist who invented it. State the following meaning. State the meaning of the symbol. This symbol means reversible or equilibrium. State the conditions used in this industrial process. Include units. So to do Haber reaction, basically we require temperature of at least 450 degrees Celsius and a pressure of 200 atmospheric pressure. So 200 atm. Name the catalyst used in this industrial process. A catalyst of iron is needed. So iron. If the pressure is increased, the yield of ammonia increases. Explain why in terms of equilibrium. We can see that there are 4 moles of reactant, but there are only 2 moles of product. Since they are gases, an increase in pressure will favor smaller volume. So an increase in pressure will favor product. If the pressure is increased, the yield of ammonia increases. Explain why in terms of equilibrium. High pressure shifts the equilibrium in forward direction. As there are fewer moles of gas on right hand side. If the temperature is increased, the rate of reaction is increases. Explain why in terms of particles. At higher temperature, particles have more energy. At higher temperature, particles have more energy. So more collisions between the particles can occur per unit time. At higher temperature, a greater percentage of reactant particles have energy above activation energy. Ammonia reacts with sulfuric acid to make a compound which is used as a fertilizer. Write the chemical equation for the reaction between ammonia and sulfuric acid. So ammonia reacts with sulfuric acid, produces ammonium sulfate. Question number 4. A student wanted to make some zinc chloride crystals. The student followed the procedure shown. Step 1. Add excess zinc powder to dilute hydrochloric acid to form aqueous zinc chloride. Step 2. Remove unreacted zinc powder from the aqueous zinc chloride. Step 3. Heat the solution until it is saturated. Step 4. Allow the saturated solution to cool and remove the crystals that form. Write the equation for the reaction in step 1. Include state symbols. So zinc powder, which is a solid, added with dilute hydrochloric acid, which is an aqueous, to produce zinc chloride, ZnCl2, which is aqueous, and it will also produce hydrogen, which is basically gas. So to balance this out, we'll need a 2 here, and the equation balances. Explain why excess zinc powder is added in step 1. So in step 1, excess zinc powder ensures that all the acid reacts to make sure all the hydrochloric acid reacts. Suggest how unreacted zinc powder is removed in step 2. Unreacted zinc powder can be removed by the process of filtration. So we can just simply filter it out. Part D. A saturated solution is formed in step 3. Suggest what is meant by the term saturated solution. A solution that can dissolve no more solute at that given temperature. That is a saturated solution. So a solution that can dissolve no more solute at a given temperature. Part E. Explain why crystals form as the solution cools in step 4. Solubility of zinc chloride decreases as the temperature decreases. Part F. Name 2 zinc compounds which react with dilute hydrochloric acid to form zinc chloride. So zinc oxide would also react, and then zinc carbonate would also react. So they would all give zinc chloride. If excess calcium metal is used instead of excess zinc powder in step 1, pure calcium chloride crystals do not form. Explain why. The reason is calcium is very reactive. So calcium will also react with water if it is in excess. When it is in excess. Part H. Some salts can be made by titration. In a titration experiment, 20 cm cube of aqueous sodium hydroxide reacts exactly with 25 cm cube of 0.1 mole per dm cube sulfuric acid to make sodium sulfate. So guys, let's write down the information. 25 cm cube and the concentration is 0.1 mole per dm cube. And on the other side we have 20 cm cube of sodium hydroxide. Circle the name of the type of reaction that takes place. Obviously, this is a neutralization reaction because acid is being base is reacting with an acid, so a neutralization reaction is taking place. First step, calculate the concentration of aqueous sodium hydroxide in gram per dm cube using the following step. Calculate the number of moles of dilute sulfuric acid. So the number of moles of dilute sulfuric acid, if we want to do the calculation, we must remember number of moles is equals to volume into concentration. So V into C. So we want to find out the number of moles of H2SO4. So volume here is given 25 cm cube. We must convert it into dm cube, so divided by 1000, into concentration, which is 0.1 mole per dm cube. So when we do the math, our answer comes 0.0025. 0.0025 mole. Determine the number of moles of sodium hydroxide which reacts with dilute sulfuric acid. So we can see that with the dilute sulfuric acid, the ratio is 1:2. So the number of moles of sodium hydroxide will be double that of sulfuric acid. So number of moles of NaOH will be 2 into 0.0025. So the answer will be 0.005 moles. The next thing, calculate the concentration of aqueous sodium hydroxide in mole per dm cube. So we know the formula, number of mole is equals to volume into concentration. Now we require concentration, so it will be number of mole divided by volume. Now we want to find out the concentration of NaOH. So number of mole is 0.005 divided by 20 over 1000 because we want to convert it into dm cube. So 0.25 mole per dm cube. 0.25 mole per dm cube. Calculate the concentration of aqueous sodium hydroxide in gram per dm cube. All right. So we know that MR of NaOH will be 23 plus 16 plus 1, which is equals to 40. So 0.25 mole per dm cube can be converted into 0.25 multiplied by 40 gram per mole. So 40 gram per dm cube, which is equals to 10 gram per dm cube. Question number 5. The table shows the names or structures of organic compound P to U. We can see here we have P, which is an alkane. So this is propane. 3 carbon compound, so this is propane. And then we have propanoic acid. So propanoic acid will be 3 carbon compound but with the carboxylic acid group. So we represent the propanoic acid. Then we have but1-ene. But1-ene, since it is but, that means there is 4 carbon, and since it is 1-ene, that means the last carbon has the double bonded carbon. Sorry, my bad. First carbon has the double bonded carbon, and we draw the remainder of the hydrogen. Propan-1-ol. Propan-1-ol, prop means 3 carbon, and since it is 1-ol, that means the first carbon has the alcohol group. We're just drawing this because it makes life really easy after this. So methyl butanoate. So methyl is CH3. and because it is the alkyl group, so there will be oxygen after that. And butanoate, meaning that there will be 4 carbons with the carboxylic acid group, so the ester. All right, give the letters of the organic compound P to U that are unsaturated hydrocarbons. So now, unsaturated hydrocarbons will have carbon-carbon double bond. So we can see there is one but1ene, and then there is U, which is propene. So R and U both are unsaturated. Describe the test for an unsaturated hydrocarbon. To test for an unsaturated hydrocarbon, we can use bromine water. So aqueous bromine. Aqueous bromine. And observation will be decolorizes. So aqueous bromine has an orange color, which will turn colorless. Or we can say turns colorless. Same thing. but1ene is an unbranched molecule. Name the unbranched isomer of but1ene. So there can be but2ene, which is basically 4 carbons in a row, but the double bond is in the middle. Draw the structure of the branched isomer but1ene. Show all of the atoms and all of the bonds. Okay, so we already did it. So but1ene, we can put 3 carbons in a row, so make it propene, and then we can put a methyl group. So the trick is basically to count that if every carbons are having 4 bonds. If every carbons are having 4 bonds, then no additional hydrogens will be needed. Part D. Dodecane is an alkane with 12 carbon atoms. Dodecane can be cracked. Write the formula of dodecane. So C12, it's an alkane. So general formula H2N plus 2. So 24 plus 2, so 26. C12H26. Give the letters of all organic compounds P to U that can be formed when dodecane is cracked. So basically when dodecane is cracked, all right, so dodecane is a very large alkane. If it is cracked, definitely we can get smaller molecules like but1ene, we can get propene, all right, we can get molecules such as propane, all right. However, QS, QT, they cannot be obtained. So PQ, PRU, this will be the product. This could be the products. Name the reagents and suggest the conditions needed to convert organic compound U into organic compound S. So organic compound U is propene, and if we want to convert it into propan-1-ol, we require steam and we require catalyst. Reagent will be steam, and condition will be a catalyst will be needed. All right, along with that 60 atmospheric pressure, 300 degrees Celsius will also be needed. Part F. Organic compound S can be converted to organic compound Q by reaction with an acidified reagent. Name the type of chemical change that happens to organic compound S. So organic compound S is propan-1-ol. It can be converted to compound Q, which is propanoic acid. So we want to convert propan-1-ol into propanoic acid. So for that we will require an oxidizer. So oxidation reaction must take place. Name the type of chemical change. The change will be oxidation. Name the acidified reagent needed for organic compound S To convert organic compound S to Q, we will require acidified potassium manganate. So the answer will be potassium manganate. Potassium manganate 7. Organic compound T is made by reacting two compounds together. Name the homologous series that the organic compound T belongs to. So organic compound T is basically a ester. So we can see that it's an ester due to the COO bond between the two carbons. So the homologous series that it belongs to is ester. Name two compounds which react together to make organic compound T. Draw the structure of each compound you have named. Show all the atoms and all of the bonds. So when naming an ester, we have to understand the breakdown. The side that has a single oxygen attached to the carbon is the alcohol. So this is the alcohol side, and the other side will be the carboxylic acid. It derived from carboxylic acid. So the alcohol will be CH3, so methanol. Name will be methanol. And the structure will be one carbon bonded with 3 hydrogens, which will be then single bonded with O and then H. The other part will be 4 carbons, since it is 4 carbons long, butanoate, so it will be butanoic acid. Deduce the molecular formula of organic compound T. So organic compound T has a total of 5 carbons in it. It has a total of 1, 2, 3, 4, 5 carbons in it. So it will be C5. All right, and if we count the other hydrogens, 3, 4, 5, 6, 7, 8, 9, 10. So C5H10O2. Polymers are large molecules built up from small molecules. State the name given to small molecules from which polymers are made. So we know polymers are made from monomers. Part B. The formula of polymer is shown here. All right, we can see CC single bond. There is a CH3 on each ends and hydrogens. Draw the structure of small molecule from which the polymer is made. Show all of the atoms and all of the bonds. So the part where we are going to see the single bond and the two hands from two sides, we're going to put them together and make it a double bond. And then we're going to draw the rest of the carbons and their bond with hydrogens. State the type of polymerization used to make polymer. Whenever there is a carbon-carbon double bond and we use the carbon-carbon double bond to make the polymer, it's an addition polymerization. So it will be addition polymerization. 3 amino acids are shown. They combine to form a part of a natural polymer. Name the type of natural polymer formed when amino acids combine. So when amino acids combine, they form protein. Next question. Complete the diagram to show part of the structure of natural polymer that forms when these 3 amino acids combine. Show all of the bonds in the linkages. So the amine part will be represented with the hand left open so that it is bonding with other amino acid, and the acid part will lose the OH, so it will be COO, and then there will be another bond which will then connect with the next nitrogen and hydrogen, and the process will then continue. Name the type of chemical reaction that takes place when this natural polymer is converted back to amino acid. So to convert a protein back to amino acid, we'll have to do a particular process known as hydrolysis. Guys, we're done with the question paper. Thank you for joining the video. All right. Hope this video helped you. If you like the video and if you like videos like this to be posted more, please like and share the videos with your friend. All right. And please subscribe the channel. It helps the channel grow. All right. Thank you. Bye bye.